Okay, my friends, this is the review for your angles and unit conversion and a couple of other topics in pre-calculus coming up here, okay? So make sure you have a calculator. It should be in degree mode since all of our angles are in degrees also. Okay, the first two are conversions. You need to learn in this class that pi radians is the same as 180 degrees. Pi radians equals 180 degrees. So if we're going to convert from radians to degrees, we need to know that the degree equals whatever the radian is times 180 divided by pi, not x. 180 divided by pi. That is our unit conversion for degrees and radians. Okay, this is our unit conversion. So negative 3 pi over 4, well, that's a radian angle measure. Anything with a pi is going to be in radians. So we have to multiply this by 180 and divide by pi. And that's all there is to it. So negative 135 is the same as negative 3 pi over 4, okay, which is also positive 225 degrees. So going the other way, if we want to convert degrees to radians, your radian angle measure is equal to the degree times pi over 180. All we do is we flip that ratio, and we're going to have a radian angle. So 240 times pi over 180. Okay, 4 pi over 3 is what that simplifies down to. Okay, so there's your conversions from degrees to radians and from radians to degrees. Okay, arc length and sector area. There are two formulas that we need to memorize. Okay, this is a degree formula, so we're going to use the degree ratio, which says arc length over circumference, which is 2 pi r, that's circumference, you should memorize that one, equals the central angle over 360. Notice how both of those are in degrees. And this is the proportion that we use if we have a degree angle. And if not, if we have it in radians, then S equals R times theta, where theta is your radian angle. So we're going to solve by cross multiplying and simplifying. Now the other one is sector area. The only thing that changes about sector area are these two things. Okay, this is now an A, standing for area. And this is now pi r squared, because that's the formula for area. Okay, the 50 over 360 stays the same. So it's sector area over pi r squared. That's the area of your circle, equals 50 over 360. So our answer is 35.343 square centimeters. Okay, our next problem is some algebra. Given a circle with a 70-foot radius, 72-foot radius, and an arc length of 90 feet, what is the measure of the central angle in degrees? Okay, so we want degrees, so we're going to use this degree ratio. We know the arc length is 90 over 2 times pi times 72, right? 2 pi r. So x is your variable. The angle is our variable in this case. So that's what we're trying to find is x. How many degrees does this have if we have a 90-foot arc length and a 72-foot radius? So the angle is 71.6 degrees. And now it says what's the area of that sector? Right, so area over pi radius squared. So pi 72 squared equals the angle which we just found, 71.6 over 360. Okay, area is a pi r squared, so area over pi r squared. So that's the area of that sector that we found the degree for right there. Okay, so there's some pretty basic things about arc length, sector area, and converting from radians to degrees and from degrees to radians. Okay, now let's talk about the other fun stuff. This is our unit conversion. Okay, the formula that we need to know is linear velocity like miles per hour or kilometers per hour, equals omega, which is angular velocity in radians per second or in revolutions per minute, times the radius that we're spinning at, right? That is the formula that we're going to use for pretty much all of these things if we have to multiply. But most of them are just conversions, right? So this one says we have propellers turning at 150 RPMs. What is the angular velocity, right? That's this angular velocity in radians per minute. So our first problem is just a conversion. We don't have to do any multiplication or any formula. We have a 150 revolutions per minute. So you need to know what RPM stands for. It stands for revolutions per minute. And now we have our conversions. We want to convert from revolutions to radians. So how many radians are there in one revolution? 2 pi. And since revolution is on top, when we divide, we want to make it go on the bottom so it cancels out. So 2 pi radians equals 1 revolution, right? It's about what's in the numerator, what's in the denominator. Well, here's my radian, there's minutes. Oh, I'm basically done. So my answer is 300 pi radians per minute, which you can type it into a calculator and get a decimal such as 942.478. Okay, both of those are correct. So that's just a unit conversion. We haven't done any formula yet. The next one says, what is the linear velocity? Well, linear velocity is this v that we're talking about. So now we have to do the formula. Velocity equals angular velocity times radius. Okay, so we can come back to our previous problem. We have a angular velocity of 942.478 radians per minute. Radians, or you could go back to the 150 RPMs if we wanted to. We might have to do some other conversion, but both of these are omegas. It doesn't really matter which one you use. Times the radius, which was 4 feet. And that's 4 feet per every 1 radian angle. Okay, so don't forget about this conversion. It's radius per radian. Don't forget about the radian part. Okay, because these ones simplify radians over radians. And I have exactly what I need, feet per minute. So there's no conversion necessary. So if I just multiply this answer by 4, 3,769.91 feet per minute is how far this thing would be revolving, right, if it were a linear speed. Okay, let's move on to number 7. In order for a lawnmower blade to cut grass, it must strike the grass at a speed of at least 900 inches per second. Okay, is this V or omega? This is your V, because look at your units. Inches is a linear unit, so this is your linear velocity. Okay, I know usually we're given omega, but in this case we're given a linear velocity. Inches per second, miles per hour, feet per minute, those are all linear speeds. Okay, And how many radians per second? So it wants us to find omega, right? This is an angular velocity question. Angular velocity. So if linear velocity equals angular times radius, what does omega equal? Linear divided by radius. If this side is multiplication, that side is division. So omega equals v divided by r. It's really important to understand that. Omega equals linear velocity, which was 900 inches every second, times radius. What's the radius that we're looking at? 6 inches. So if we're dividing, where does that go in my fraction? Goes on the bottom. 6 inches goes on the bottom. 1 radian angle goes on top. Okay, that's important to understand. Division happens in the denominator. So if we're dividing by 6, that means we put it down there in the denominator. So let's see, the inches cancel out with the inches, radians per second. This is just a division problem. There's no conversion necessary. So our blade must be spinning at 150 radians per second. So how many revolutions per minute is this? That's our next question. How many RPMs? Well, if I have 150 rads for every second, how many rads are in 1 revolution? 2 pi rads. And how many seconds are in a minute? 60 seconds. So seconds goes on top, 1 minute goes on bottom, so that the like units on top and bottom can divide each other out. So 150 times 60 divided by 2 pi. So 1,432.39 revolutions per minute. Okay, so there's some good stuff there converting from one unit to another. V equals omega times r. So here's all the work here for number 9. We get 90 degrees per second and 32.130 miles per hour. Okay, pause the video if you need to copy this down. All right, our last one is some trig stuff. Okay, so here's our drawing of our trig. There's a state trooper that sits 30 feet from the road, and he's measuring the angle after 1 second of driving. Okay, it's pretty quick. So if the angle measures 15 degrees, how fast is the truck driving? So in other words, we can use our trigonometry to figure out the distance that truck drove in 1 second. Okay, so 15 is our angle, 30 degrees is the opposite side. We're trying to find D, the adjacent side. Which trig shall we use? That would be the tangent ratio. So the tangent of 15 equals 30 over D. Adjacent under opposite. Opposite over adjacent. So that distance traveled is 30 divided by the tangent of 15 degrees, which is, let's see, 111.962 feet is how far that truck has driven. And how long did it take it to travel there? 1 second. Okay, so there's your answer in feet per second. So now let's convert to miles per hour. Miles per hour. So we'll do that over here off to the side. 111.962 feet every second. Okay, there are 3,600 seconds in 1 hour. Okay, you can go from seconds to minutes and minutes to hours. It's the same thing as 3,600 seconds for 1 hour. And in 1 mile, there is 5,280 feet. So if we do this multiplication, the truck was going 76.34 miles per hour. We'll read down in part C that that's speeding. The speed limit was only 55. So the next part says we now have a 20-degree angle. So the truck is driving, we use the same exact equation. The only thing that changes is 15 is now at 20 degrees, and our feet per second is now 82.424. So now let's convert that into miles per hour. And that comes out to be 56.2 miles per hour. Okay, so this time, technically he was not speeding, because this says we don't get a ticket until we go 5 miles per hour or more over the limit. So he's okay at 56 miles per hour, but originally at 76, that's speeding. Okay? So let's see, the last one is we have to be doing at least 60 miles per hour before we can get a ticket. So we're going to convert this into feet per second and then figure out what that angle has got to be. So 88 feet per second is what that converts to. Okay? So we know that we are speeding if we're doing more than 88 feet per second. So the tangent of theta equals 30 over 88. So our angle has to be less than the inverse tan of 30 over 88. Okay? So the inverse tan, that's how we find an angle, of 30 divided by 88 is 18.8 degrees. So as long as that angle that the officer found is less than 18.8, you are not speeding. Okay? So yes, this test is a lot of conversion from one unit to another. So make sure you know your conversions for the test tomorrow. All right, do great. See you then.